Oh, it's a grade nines. Okay, today is going to be a little bit of fun and games because we're going on to more complex exponents. Okay, now the slides are telling you to do a whole lot of things like use law 3, 4, 1, 4, and all of this. What I want you to do is just work through it systematically. Okay, and you will pick up which laws to use. All right, so you guys should have good practice now on all of your exponential laws. And we're going to apply that, okay? So if I look at example 1, I'm just going to get it down and then we can work through it. Okay, so I know it looks a little bit hectic, but it isn't that bad. Right, first of all, what I'm going to do is I'm going to divide the numbers. So as you can see, 4 will go into itself once, 4 will go into there twice. So we're left with a 2. Now remember, if bases are the same and we are dividing, we subtract the exponents. So this will be a to the power of 2 minus the bottom exponent, which is minus 2. Sorry, my housemate is watching Netflix, guys. You'll have to deal. All right. Then with B, we've got 3 minus the bottom one, which is 2. Then we've got C minus 2 minus 1. Okay, so always take the top minus the bottom, even if it is a negative like this. I've just kept to the laws. Okay, I'm going to simplify each one of these exponents. So here we get 2 minus minus 2, so the minus and the minus will give us a plus, so it becomes 2 plus 2, which is 4. B to the power of 3 minus 2 is 1. C to the power of, now, minus 2 minus minus 1, so that the minus and the minus will give us a plus, so it's minus 2 plus 1, which gives us minus 1. Now, that is not your final answer. The reason why is because we have a negative exponent. So remember, negative exponents always want to be in the opposite place. So just remember that this whole thing over here is over an invisible 1. Let's just see here. So this whole thing is over an invisible 1. Okay. So the things with the positive exponents are going to stay where they want. So that has an invisible 1 there as well. Okay. So they are all staying up at the top, those 3 there, because they all have positive exponents. The one that's going to go to the bottom is this one here. And as soon as I take it to the bottom, its exponent becomes positive. All right, so you see it wasn't that bad. It's just they're throwing a whole bunch of stuff at you and I'm just applying the relevant laws. Okay, let's have a look at example 2. Okay, so there's example 2. Just going to get a fresh page here and write it down. As you guys can see, there is the answer, but we will get to the answer. So we've got x squared, y to the minus 3 to the minus 1 times x to the minus 2, y cubed, all over x to the 5, y cubed. All right. Okay, grade 9s, let's get stuck in. So the first thing I'm going to do is I'm going to get rid of this bracket here. Now remember, if you have something to the power of something raised to another power, we multiply those exponents. So this would become x to the power of 2 multiplied by 1, minus 1. Y to the power of minus 3 multiplied by minus 1, because we have something to the power of something raised to another power. Okay, I'm going to leave everything else exactly the same. Okay. Right, let's just simplify these and then we can continue after that. So 2 times minus 1 is minus 2. y to the power of 3 minus 3 times minus 1 is 3 times by x to the minus 2, y to the 3 all over x to the 5, y to the 3. Okay, so now what I'm going to do is I'm going to apply law 1 and 2. When bases are the same and we're multiplying, we add the exponents. Also, when bases are the same and we're dividing, we subtract. Okay, so up at the top, we are multiplying, so I'm going to add those exponents. So it's minus 2 plus minus 2. Okay, so you see I didn't do anything fancy there, guys. It's minus 2 plus minus 2. But now I need to subtract 5. And the reason why is because I'm dividing. Okay, I go to my next variable now, y, and we've got 3 plus 3, y, because we are multiplying. Then I subtract 3 because we are dividing. Okay, now I can just simplify these exponents. So that'll give us a minus, and then we've got minus 2 gives us minus 4, minus 5 is minus 9. Okay, y to the power of 3 plus 3 is 6, minus 3 is 3. Remember that this is all over an invisible 1. So negative exponents want to be in the opposite place. So he wants to be at the bottom, and he wants to stay up at the top. And there's our final answer. Okay, let's have a look at example 3. Okay, let's just get this down. Five squared to the power of minus 2 times 5 to the 4 all over 5 squared times 5 to the minus 12 in a square root. All right. Okay, first things first, let's get rid of this bracket here. So we've got something to the power of something raised to another power. So we multiply those exponents. So this would be 5 to the power of 2 times minus 2 times 5 to the 4 all over 5 squared. Now remember what we do here, grade 9s, with a square root, we divide that power by 2. So times 5 to the minus 12 over 2. Okay, let's simplify those two there, and we get 5 to the power of 2 times minus 2 is minus 4, multiplied by 5 to the 4 all over 5 squared, multiplied by minus 12 divided by 2 is minus 6. Okay, now I'm going to use laws 1 and 2, and they say if bases are the same and we're multiplying, we divide we add the exponents. Okay, so we've got 5 to the minus 4 plus 4. Then if we're dividing, we subtract. So minus 2 minus minus 6. I keep that sign there. Okay, this is a fairly long one, but we can do it. So minus 4 plus 4 is 0. Minus 2 is minus 2. Minus and a minus gives us a plus 6. So minus 2 plus 6 is 4. Okay. And then you can leave your answer in exponential form like that. That's fine, grade 9s. Right, so for homework, I'm going to be uploading a worksheet to Teams. You can just do that worksheet there. Thanks, grade 9s.